Download this code from codegive.com, link in the description below. Data transfer objects, DTOs, versus input validation, a comprehensive guide with code examples. This tutorial dives deep into two crucial concepts in software development: data transfer objects, DTOs, and input validation. While seemingly related, they serve distinct purposes and address different challenges. Understanding their roles and how they interact is essential for building robust and maintainable applications. 1. What are data transfer objects, DTOs? DTOs are simple objects used to transfer data between layers of an application. Think of them as containers that hold data without any associated business logic. They are primarily designed to reduce the number of calls across process boundaries, example between the presentation layer and the business layer or across network connections. 1.1. Why use DTOs? Encapsulation. They encapsulate the data to be transferred, providing a well-defined structure. Reduced network overhead. Instead of transferring multiple individual parameters, you transfer a single DTO, reducing the number of round trips across network boundaries. This is particularly important for distributed systems and web services. Decoupling. DTOs decouple the data structure from the underlying data models or entities. Changes to the entity model don't necessarily require changes to the layers consuming the DTOs. This improves maintainability and reduces the impact of refactoring. Versioning. DTOs can be versioned, allowing for changes to the underlying data model without breaking compatibility with older clients. Serialization/deserialization. DTOs are designed to be easily serializable, example to JSON, XML, and deserializable, making them ideal for transferring data over the network. Security. DTOs can be tailored to expose only the necessary data, preventing sensitive information from being inadvertently leaked to the client. 1.2. Characteristics of a DTO. Simple data holders. Primarily consist of fields/properties, usually private with getters and setters, to hold data. No business logic. DTOs should not contain any business logic, such as calculations, validations, or data transformations. This keeps them focused on their primary purpose, data transfer. Immutable, often preferred while not mandatory, making DTOs immutable, i.e., their values cannot be changed after creation, is often a good practice. Immutability simplifies reasoning about the data and prevents accidental modifications. Plain old Java objects, POJOs. In Java, DTOs are often implemented as POJOs or POJOs-like classes, if using other languages. They adhere to a simple structure without dependencies on frameworks. 1.3. Example, Java. 2. What is input validation? Input validation is the process of ensuring that data entered into a system is correct, complete, and consistent before it is processed. This is a critical security measure to prevent malicious or invalid data from corrupting your application or causing security vulnerabilities. 2.1. Why is input validation important? Security prevents injection attacks, example SQL injection, cross-site scripting, XSS, where attackers inject malicious code into the input data. Data integrity ensures that data conforms to expected formats and ranges, preventing data corruption and errors in calculations. Application stability prevents application crashes or unexpected behavior caused by invalid data. User experience provides meaningful error messages to users, guiding them to correct their input. Compliance meets regulatory requirements for data security and privacy, example GDPR, HIPAA. 2.2. Where to validate input client-side provides immediate feedback to the user in the browser, example using JavaScript. This improves the user experience and reduces server load, but should never be relied on as the only form of validation. Client-side validation can be easily bypassed by attackers. Server-side this is the most important level of validation. All input data must be validated on the server before being processed or stored in the database. Server-side validation provides the ultimate protection against malicious or invalid data. Database level some validation can also be performed at the database level, using constraints, triggers, and stored procedures. This adds an extra layer of protection. 2.3. Types of validation format validation checking if the data matches a specific format, example email address, phone number, date. Regular expressions are often used for this. Type validation ensuring that the data is of the correct type, example integer, string, boolean. Range validation verifying that the data falls within an acceptable range, example age between 0 and 120, quantity greater than 0. Length validation checking the length of strings, example maximum length of a password, minimum length of a username. Presence validation ensuring that required fields are not empty or null. Consistency validation verifying that related fields are consistent with each other, example start date is before end date. Whitelist validation, strongest checking that the input is one of a known set of allowed values, example valid product categories, allowed roles. This is generally considered the strongest form of validation. Blacklist validation, weakest checking that the input does not contain specific disallowed characters or words. This is generally less effective because it's difficult to anticipate all possible malicious inputs. 2.4. Example, Java, using bean validation, JSR 303/380. Bean validation provides a standardized way to validate Java objects. It uses annotations to define validation constraints. This example uses Hibernate Validator, a popular implementation of bean validation. First, you'll need to add the necessary dependencies to your project, example using Maven or Gradle. Explanation **** at not null, at size, at email, at not blank, at min, at max. These are bean validation annotations that specify validation constraints. Validator factory, validator, used to create a validator instance. Validator.validate, user input, validates the user input object against the defined constraints. Constraint violation, represents a validation error. The code iterates through the violations and prints the property path and error message for each violation. Output of the example ***. 3. DTOs versus input validation, key differences. Feature DTO input validation. Purpose data transfer between layers/systems ensuring data quality and security. Focus data structure and serialization data correctness and security checks. Location throughout the application primarily at the application entry points. Content raw data, possibly formatted for display constraints, rules, and error handling. Business logic none often coupled with error handling and reporting. 4. How DTOs and input validation work together. While DTOs and input validation are distinct concepts, they often work together in a well-designed application. The typical flow is as follows. 1. Input data *, the user or client submits data, example through a web form or API request. 2. Input validation *. The input data is first received by a component responsible for handling external requests, example a controller in a web application. Before creating any entities or performing any business logic, input validation is performed. This validation is done on an input object, like user input in the example above, not on a DTO, or an entity. If validation fails, an error response is returned to the client, indicating the invalid input. 3. Data transformation, possibly. If validation succeeds, the validated input data is then used to create a DTO. This might involve some data transformation or formatting, example converting a date string to a local date object. 4. DTO transfer *. The DTO is passed to the business logic layer or other layers of the application. 5. Further processing *. The business logic layer processes the data in the DTO, performs any necessary calculations or operations, and interacts with the data access layer. 6. Data access layer, DAL. The DAL interacts with the database to persist or retrieve data. It might convert the DTO data to entity objects, if using an ORM like JPA/Hibernate. 7. DTO creation for response, possibly when returning data to the client, another DTO might be created to encapsulate the data to be returned. This DTO might contain a subset of the data from the entity object or calculated values. 5. Code example illustrating DTOs and input validation. This example combines DTOs and input validation in a simplified scenario. Explanation *. 1. User input *. This class represents the data received from the client. It's annotated with bean validation constraints. 2. User DTO *. This class is the DTO, used to transfer user data between layers. 3. User service *. This class simulates a service layer that handles user creation. It first validates the user input object. If validation fails, it throws an illegal argument exception. You could also return an error response object. If validation succeeds, it creates a user DTO using the validated data from the user input and returns the DTO. This demonstrates the transformation from raw input to a DTO. Important considerations Error handling Proper error handling is essential. Return meaningful error messages to the clients so they can correct their input. Use appropriate exception handling to prevent application crashes. Security best practices Always sanitize input data in addition to validation. Sanitization involves removing or escaping potentially harmful characters from the input. For example, HTML escaping can prevent XSS attacks. Localization Consider localizing error messages to provide a better user experience for users in different regions. Framework support Many frameworks provide built-in support for input validation and DTOs, example Spring Framework in Java, ASP.NET MVC in C, Django REST Framework in Python. Leverage these features to simplify your code and improve consistency. In summary, DTOs are for structuring and transferring data, while input validation is for ensuring data quality and security. They are both important parts of building robust applications, but they have distinct roles and responsibilities. Use input objects for validating the incoming data and then transform that valid data into DTOs.